Today I am discussing analysis of perfect frame. A frame is a structure made up of several bars or members connected together by belts or rivets. Different sections of members are circular, rectangular, angle section, I section, T section, channel section, and composite sections. Classification of frames. Frames are classified into perfect frame and imperfect frame. A perfect frame is that it's made up of members just sufficient to keep it in equilibrium when loaded without any change in its shape. Simplest perfect frame is a triangle. Number of members in a perfect frame may be expressed by the relation n is equal to 2j minus 3, where n is equal to number of members and j is equal to number of joints. This is a basic perfect frame triangle. It has 3 joints, ABC joints. So 3 j is equal to 3, 2 into 3 minus 3, that is equal to 3. The number of members is also 3. Another example, here the 4 joints, so j is equal to 4, 2j minus 3, 2 into 4 minus 3, that is equal to 5. Here the 5 members, so it's a perfect frame. Another example, here 5 joints, A, B, C, D, 5 joints, and so j is equal to 5, 2 into 5 minus 3, that is equal to 7. So here 7 members. So this is also a perfect frame. Imperfect frame. An imperfect frame does not satisfy the equation n is equal to 2j minus 3. Imperfect frames are classified into two types, deficient frame and redundant frame. Deficient frame is an imperfect frame which the number of members is less than 2j minus 3. And redundant frame, the number of members is more than 2j minus 3. Assumptions, all the members are pinned joints and the frames are loaded only at the joints, and the frame is a perfect frame. Analytical method for finding out the forces. There are two methods, methods of joints and method of sections. In method of joints, every joint is treated as a free body diagram and it is in equilibrium. Say one example, a triangle frame. It has 3 joints, 1, 2, 3, and each joint is drawn separately. This joint one is a free body diagram which is in equilibrium. The figure 2, this joint 2 is also in equilibrium. So draw the joint 3, free body diagram of joint 3, and this is also in equilibrium. Now the unknown forces are then determined by equilibrium equations by sigma v is equal to 0 and sigma h is equal to 0. That is, all the vertical forces and all the horizontal forces are equal to 0. Some revision is required. So the resolution of forces, if the force F is acting at an angle theta with the horizontal, then this is resolved into vertical component and horizontal components. This is the sides of a rectangle. The horizontal component is equal to F cos theta and vertical component is F sin theta. As force is in second quadrant, same procedure. F cos theta, horizontal component, F sin theta, vertical component is third quadrant. This is fourth quadrant. The horizontal component is always F cos theta and vertical component is F sin theta. If the angle is makes it to vertical, the angle is makes it to vertical. This is reverse. This here angle is makes it to horizontal. Theta is horizontal. Then horizontal component is F cos theta and vertical component is F sin theta. Instead of horizontal angle, if the angle is vertical, this is reverse. Horizontal component is F sin theta and vertical component will be F cos theta. And for a horizontal force, there is no vertical component. And for a vertical component, there is no horizontal force. The following steps are adopted for analysis of simply supported frames. First, we calculate the support reactions. Then, select any joints. And joint is in equilibrium. Draw the free body diagram of the joints. And joint is selected in such a way that the maximum unknown forces at the joint is not more than 2. Because we have only two equations, sigma v is equal to 0 and sigma h is equal to 0. So we have only two equations, so the maximum unknowns should be not more than 2. Mark the direction of the forces in the members. So we have assumed the forces in any direction, and if the force is towards the joints or the push the joints, it is compression, and if the force is Pull the joints or away the joints is tension. Resolve all the forces vertically and equate it to 0. That is sigma B is equal to 0 or upward force equal to downward force. Resolve all the forces horizontally and equate to 0. That is leftward force equal to rightward force. Example, the truss ABC has 1 meter, angle B is 60 degree and angle C is 30 degree. At joint a 10 kilometer load is acting. From this triangle, angle B is 60 degree and angle C is 30 degree. So the angle A should be 90 degree. So this is a right angle triangle. Therefore, the opposite side of the 90 is BC, that is hypotenuse. So sin theta equals opposite side by hypotenuse, that is AB by BC, and BC is equal to 5 meter. Therefore, AB by 5 or AB is equal to 5 into sin 30, that is 2.5 meter. And from the triangle ABD, angle B is 60 degree. So the cos 60 is equal to adjacent BD by hypotenuse AB. BD by AB, and AB already calculated 2.5. BD by 2.5. So BD is equal to 2.5 into cos 60, that is 1.25. Then find the reactions RB and RC. Reaction calculated taking moment about B, then RC into 5 RC equal to 10 into distance BD. Distance BD is 1.25. So 10 into 1.25. Therefore, RC is equal to 2.5 kilonewton. And RC plus RB is equal to 10. So RB is equal to 10 minus 2.5, it is 7.5 kilonewton. Then draw the joint B. Then joint B is in equilibrium. Resolve all the forces vertically. Here there are two vertical forces, 7 kilonewton upward and the vertical component of AB acting downward. That is the vertical component of AB, the angle makes with the horizontal, so it is FAB sin 60. So equating these two, that is 7.5 is equal to FAB sin 60. So therefore, FAB is equal to 10.5 by sin 60. That is equal to 8.6 kilonewton. And the force, the nature of the force is AB is, we are assuming here the direction of the force is towards the joint B. The arrow is showing towards the joint B, so it is compression. Then the horizontally. Here the horizontal force are BC force. We are assuming this in the rightward direction, and the vertical component of horizontal component of AB, FAB, cos 60 is towards the leftward. So leftward is equal to rightward. FBC is equal to FAB cos 60. FBC is equal to 0.66 is FAB, and cos 60 that is 4.33 kilonewton. This tension. This is the arrow is away the joint. That is tension. Then consider the joint C. So another joint. Then resolve vertically. Here the 2.5 vertical support reaction vertical upward, and the vertical component of AC acting downward, that is F AC sin 30. So equating these two, we get FAC. And another example, from this figure, you find out the distance AF. The total span is 6 meter. So here AE is 3 meter, ED is 3 meter, and AF is 1.5 meter. This is 4.5 meter. So we calculate AF and AG. Let's find the support reaction. Taking moment about A. RD into 6. 6 RD. That is equal to 2 into AF. AF is 1.5. The 2 into 1.5 and 4 into AG. AG is 4.5. 4 into 4.5. Therefore, RD is equal to 3.5 kilonewton or RA is equal to 2.5 kilonewton. Then consider joint A. Draw the free body diagram of joint A. Here, so vertically, the vertical forces are 2.5 kilonewton reaction upward, and the vertical component of AB is acting downward. That is FAB sine 60. So equating these two, we get 2.5 is equal to FAB sine 60. We get the FAB is equal to 2.887 kilonewton. This is compression. Then resolving horizontally, horizontal forces are AE horizontal force and the horizontal component of AB is FAB cos 60. So resolving, equating these two equations horizontally, AE is equal to FAB cos 60. Therefore, FAE is equal to 1.44 kilonewton. And the arrow is away the joint, so it is tension. Then consider joint D. Draw the freeboard diagram of the joint D. Resolve vertically. Vertical forces are 3.5 kilonewton upward and the vertical component of CD acting downward. FCD sine 60. That is 3.5 is equal to FCD sine 60. Therefore, FD is equal to FCD is equal to 4.041 kilonewton compression. Then resolving vertically. Vertical force horizontally. Now the resolving horizontally. The horizontal force are FED horizontal force and the horizontal component of CD FED cos 60. So equating FD is equal to FCD cos 60 or FD is equal to 2.021 kilonewton tension. Then consider joint B. Resolving vertically, 2.5 vertical force and vertical component of BE sine 60 and vertical component of AB FAB sine 60 upward. Then equating 2 is acting downward, FB sine 60 is acting downward, that is equal to FAB sine 60 upward. So FB is equal to 5.78 kilonewton tension. Then resolving the forces horizontally. Horizontal forces FBC is horizontal and the horizontal component of AB FAB cos 60 and horizontal component of E FBE cos 60. So these two forces are towards right and FBC is towards left. So FBC is equal to FAB cos 60 plus FBE cos 60. So FBC is equal to 1.732 kilonewton compression. Then consider joint C. Resolving vertically, 4 kilonewton is acting downward and the FC horizontal vertical component of FC is FC sine 60 and vertical component of FCD sine 60. So 4 is acting downward, other two forces are acting upward. So 4 is equal to FCE sine 60 plus FCD sine 60. So FCD is equal to 5.7678 kilonewton. The direction of force is towards the joint, so it is compressed.